I'm glad that Lofi mentioned a role of a public key administrator that would set minimum requirements that need to be fulfilled before an issuing authority CA certificate can be included in a trusted master list. Next. We strongly suggest working towards a set of common issuing authority policy, process, and technology requirements. We believe that testing and certification in the context of an mDL assurance program could be instrumental to obtaining assurance that these requirements are met and in conveying evidence of that assurance. Let's have a look at some key areas which will likely be addressed: the public key infrastructure, the provisioning process, and the mDL app. Next. To start with the latter, mDL apps need to function properly and be interoperable with mDL reader implementations that conform to ISO 18013 Part 5. mDLs need to be properly secured to protect against unauthorized use or identity theft. And privacy-enhancing technology needs to be implemented to give the mDL holder full control over their data and to enforce that only data is being shared that the holder consents to. To obtain assurance that these objectives are met, an mDL assurance program may provide privacy review, cybersecurity evaluation, and conformity assessment against ISO 18013 Part 5. Next. To look at the provisioning process and PKI, let's zoom in into some key functions in the issuing authority infrastructure. Next. First of all, we have the system of record, which is the source of truth when it comes to the holder's identity information. The identity information that is in the system of record is the result of an enrollment process which may be related compliant and in which the necessary identity assurance processes have been implemented, potentially according to standards like NIST SP 863. Next. The issuing authority PKI is as important as the system of record when it comes to trusting an mDL. The issuing authority's electronic signature is placed on the mDL data that is provisioned to an mDL. That electronic signature, which is created with the issuing authority's private key, provides proof of origin, integrity, and authenticity of the mDL. Control of that private key enables signing on behalf of the issuing authority. That private key should be, therefore, one of the best kept secrets in a state or province. The corresponding public key is made available in the issuing authority's public key certificate. The issuing authority CA certificate is used by an mDL reader to verify the electronic signature on the mDL data to confirm that the mDL is authentic and originates from the issuing authority. Without that certificate, an mDL cannot be authenticated. The issuing authority CA public key certificate should therefore belong to the most prominently published information within the issuing jurisdiction and far beyond. The requirements for protection of the issuing authority CA private key and conditions for its use are laid down in a certificate policy and certification practice statement. Typically, there are requirements for private keys to be stored in a hardware security module, requirements for physical and logical access to the issuing authority CA system, and the hardware security module for key management, etc. In short, requirements for people, process, and technology involved in PKI operations. Next. In the data preparation and document signing function, a driving license holder's information from the system of record is structured into an ISO 18013 Part 5 compliant data structure. This is combined with some information from the mDL app and then electronically signed to establish trust in the data. Next. Credential management is a function where processes for enrollment and user identification, mDL app and device discovery, and the actual provisioning takes place, and where the digital credential status is maintained. This function is essential in the process of tying the mDL holder, their record in the system, the app, and the mobile device together, and to ensure that the right set of data ends up on the right mobile device. If the processes in these four key functions are correctly implemented and the protocols for interaction between those functions and the mDL are well protected and secure, an mDL can become as trustworthy as a biometric passport. Next. To obtain assurance that an issuing authority's mDL implementation indeed is highly trustworthy, a number of assurance activities can be carried out. During a PKI audit, processes and technology can be reviewed and confirmed to implement the requirements and meet the objectives laid down in the certificate policy and certification practice statement. Cybersecurity assessment and penetration tests can provide assurance that the issuing authority infrastructure is reasonably secured and protected from unauthorized use. ISO 18013 Part 5 conformity assessment on the mDL data structures and PKI certificate formats provides the assurance that the data preparation and document signing function produces data sets that can be universally interpreted by compliant mDL readers and so contribute to achieving the objective of global interoperability. Next. Within the context of an mDL assurance program, an issuing authority can collect evidence from the various assurance activities. With the necessary test reports and certificates, the issuing authority can demonstrate to the public key administrator that their processes and technology fulfill the applicable policies and requirements. Upon confirmation of that compliance, the issuing authority CA certificate should be admitted on the master list, which can be used by mDL verifiers and relying parties in their mDL readers to confidently accept trusted and interoperable mDLs.